Welcome to this explainer from Forge College. You just survived the capstone build deploying and validating the full dApp lesson using plain Rust. Give yourself a massive pat on the back and, maybe grab some ice for your typing fingers. Today, we're diving into our Anchor framework overview. This is a key part of getting started with Anchor, within the Anchor Framework Essentials module, which sits right inside your Solana Development Tools track. Now that you've figured out how to build a house by manually wiring every single outlet by hand, let's introduce you to the ultimate upgrade. Here's a quick roadmap for today. We'll start by entering the Anchor framework itself. Then we'll decode the Anchor.toml file, look at mapping program IDs, run through a quick staging exercise, and finish up with your takeaways and next steps. Let's get to it. All right, Section 1. Enter the Anchor framework, the ultimate engineering upgrade. Think about the stark contrast here. On one side, we have plain Rust development. It's literally like manually running copper wire through your walls. It takes an incredible amount of patience, and just one typo means you're basically tearing the drywall out to find the bug. On the flip side, we have the Anchor framework. It's this deterministic, completely frictionless smart home blueprint that just does all that heavy lifting for you. So what exactly is it? Well, the Anchor framework is essentially a Rust-focused toolkit designed entirely to save your sanity during Solana development. It relies on three main pillars: attribute macros, an IDL, and standard layouts. Without getting too bogged down in the actual code just yet, the really big takeaway here is that Anchor gives you a clean, predictable, and totally standardized workspace. Now, one of those key pillars is the IDL, or Interface Definition Language. You can think of it as a magical translation manual. It acts as this perfect bridge that tells your front-end client exactly what your on-chain Rust program needs to function. So there's no more guessing, no more manually matching data types. The IDL just handles all the translation for you. Moving on to Section 2, decoding the Anchor.toml file, the master blueprint. Using the rule of threes, we can deconstruct the absolute central brain of an Anchor workspace, which is the Anchor.toml file. First up is the workspace section. This defines your repository composition. It's basically telling Anchor where your programs actually live. Second is the provider section, which specifies your cluster and wallets. And third is the programs block, which is what maps your human-readable crate names directly to their on-chain IDs. Let's just zoom in on that middle piece for a second, the provider. The provider tells the Anchor command line interface which Solana cluster you want to target and which key pair wallet to use for your deployments. Think of the provider block as your master control dial. Wherever you point that dial, whether it's a local testnet or the main network, that is exactly where your CLI operations are going to happen. All right, Section 3, mapping program IDs, the shapeshifter problem. This brings us to a super relatable developer nightmare. How on earth do we handle different program IDs across our local, dev, and main networks without completely rewriting our source code every single time? Because remember, every time you deploy to a new environment, your program gets a brand new, totally unique public key. Just trace the lifecycle of a typical program on this timeline. Day 1, you're building on your local validator. Day 14, your continuous integration pipeline hits the devnet. And by day 30, you are pushing a massive production release to mainnet. That's 3 different deployments, which means 3 totally different IDs. If you try to hardcode those, you're going to end up with a massive, tangled mess on your hands. So, to solve that, we have this core mantra in Anchor development. The crate name stays exactly the same, only the ID changes per environment. Your human-readable package name, let's say we call it escrow, remains completely fixed in your files. Anchor automatically swaps out the cryptic ID string behind the scenes based entirely on which environment you're targeting. Pretty clever, right? Let's see this in action with Section 4, staging environment exercise, the mental sandbox. Here's how ridiculously simple this is in Anchor. Step 1, you just confirm your crate folder and package actually match the name escrow. Step 2, you open your Anchor.toml file and add a new block called programs.staging, and you paste your brand new staging ID right in there. And step 3, you simply change your provider cluster from your local setup over to staging. That's it. And if we execute those 3 steps correctly, everything cascades perfectly down the line. The framework automatically embeds that staging ID into your generated TypeScript client. This completely prevents those nasty mismatched artifact errors where your code is desperately looking for a local ID on a live server. It creates a single source of truth, meaning your client will find the exact staging address with absolutely 0 manual code changes from you. bringing us to Section 5, Takeaways and Next Steps, Preparing to Build. Before you get back to building, let's lock in your 3 golden rules. First, your program names and the configuration must perfectly align with your crates. Second, the program's tables in your .toml file are your absolute single source of truth for environment IDs. And third, the provider block sets your CLI context. It is the steering wheel for all your deployments. If you follow these rules, you're going to ensure completely reproducible and friction-free pipelines. Which brings us right to the horizon. Your next lesson is environment setup and workspace configuration. Now that you actually understand the underlying theory, get ready to install the Anchor CLI, initialize a real workspace, and run these configurations against a live local validator. I want to leave you with this final, somewhat provocative thought. Is your workspace adapting to your environment, or are you still hard-coding the past? Let the framework do the heavy lifting for you. Thank you so much for joining me for this explainer, brought to you by Forge College. I highly encourage you to visit forge.college to master even more Web3 subjects, save yourself from those manual coding headaches, and truly elevate your engineering skills. See you next time.